I'm here today with Simon Levin, who's the James McDonnell Distinguished University Professor in Ecology and Evolutionary Biology at Princeton University, and also the Director of the Center for Biocomplexity in the Princeton Environmental Institute. So to get started today, how would you explain the main focus of your research? What are your overarching goals in your research?
That's a very difficult question. My research is all over the place. I began as a pure mathematician, but interested in applying it to problems of importance to the world, which largely meant ecological and environmental problems, but quickly evolved to include infectious diseases. And in general, I think the unifying theme of my work has to do with trying to understand the unintended, emergent, macroscopic consequences of individual actions. To some extent, obviously that includes how the decisions individuals made and the risks they take when it comes to the current pandemic or any other outbreak of an infectious disease and the implications for the spread in the population. It includes their decisions in terms of getting vaccinated, in terms of antibiotic use. But it also includes the other actions of individuals in our societies, even in terms of financial systems and the decisions we make there. It also extends all the way down to considering similar phenomena in ecological system, all the way down to bacteria who engage in collective action. That's what keeps our dentists in business, because we get biofilms on our teeth. Those are amalgams of many different species of bacteria who, in a sense, collaborate in order to produce these biofilms, which are not good for our teeth, but are ultimately good for the bacteria. So all of these are problems which, first of all, involve scaling and understanding from individuals up to collectives. And automatically that means conflicts between levels, what we call public goods problems. And they occupy a lot of my time. How do we protect society against the outbreak of disease? What are the incentives for individuals to get vaccinated? Of course, there are strong individual incentives in the case of something like COVID-19 or influenza, where you want to protect yourself. But for many diseases like smallpox, they are not present in the population, or they may be, or at a time when they were at low density, the individual protection dimension may have been small, and people began to worry about side effects, whereas there is what we call herd immunity. You've all heard a lot about herd immunity in terms of the current pandemic, and one wants to get individuals to cooperate to protect society. Well, we run into similar conflicts when it comes to effects of climate change, pollution, overuse of resources, where none of us perhaps has sufficient, unless we're very civic-minded, individual incentive to take actions in the collective good. But if none of us does that, then we're all in trouble. So how do we get individuals to cooperate and get us to the social optimum or somewhere close to that? So those are the sorts of problems I worry about. And I take a lot, everywhere from human societies all the way down to bacteria. And I work on microbial systems and other non-human animal systems, because I want to gain insights to help me understand how to address these problems in human societies.
Wow, that is the absolute depth and breadth of biocomplexity for sure. So how do you see this work being supported within the expeditions community and enhanced by being a part of the expeditions community?
Well, the involvement with the expedition project has been one of the most exciting projects I've become involved in the last several years, because it brings together so much complementary expertise from people in different disciplines, and the tremendous power, computing power, that University of Virginia has through the Biocomplexity Institute that Madhav Marath directs, to be able to explore these relationships between individual actions and collective outcomes. The team at the University of Virginia was one of the first to develop agent-based models of infectious diseases. In fact, they did that through, when they were at Los Alamos, through a program called MIDAS, for which I was the chair of the steering committee overall, the MIDAS program at NIH. So I was well aware of this work. So when Madhav Marath approached me, I saw this collaboration as a terrific opportunity to take what we did, which was computational and mathematical, but to first of all elevate it to a much more powerful computing platform, and also bring in the expertise of all the people that Madhav has assembled, including him, of course, and Steve Eubank and the others at Virginia, but the others that he's brought in. And so and everything I expected to come out of this has happened in spades. And we've got multiple collaborations, none of which we could have carried out on our own, and looking at the network dynamics of the spread of diseases. And as you know, we actually began this long before we knew anything about COVID. So these are not problems unique to COVID. They're problems we thought would be appropriate to dealing with infectious diseases and epidemics more generally, and getting ready for the next pandemic. Unfortunately, the timing was very good, in that when COVID broke out, we were ready to go. And so we're expecting great things out of this.
Yes, pandemic is bad for society in general, but from a research perspective, we absolutely were ready to tackle it. Absolutely. So this is a great team. So thinking back on your career, what is the most surprising or interesting or weird place that your research has taken you?
Oh, that's a tough question. As I told you, I was trained as basically a pure mathematician, although in the methods that were useful for applications. And I went out and I did a postdoctoral fellowship with George Dantzig, famous early pioneer in operations research, who developed the simplex method, one of the most famous methods in operations research. Well, George and I didn't work on linear programming problems. We worked on a range of problems in biology, and I learned from him that one ought to take one's skills and not be afraid to tackle any problem. So my career has rarely followed a path laid out much in advance. It's been an opportunistic career, and I've benefited so much from collaborations as well. So I find it hard to answer your question, because my career has been so much a case of finding new opportunities as new challenges result. And certainly, but we got started working on influenza about 30 years ago, and the methods obviously pre-adapted us to address the current epidemic. But it's been almost, my research path has been almost a Markov process, where at each stage I get prepared to tackle the next. Yeah, in the last 10 years, I've started, actually a little bit more than 10 years. In 2006, I attended a workshop organized by the National Research Council and the New York Fed, that was led at the time by Timothy Geithner, which was starting to worry about what was called systemic risk in banking systems. Now that was something I had thought not at all about before. And we published a paper, or George Sugihara and I, who were at that meeting together with the late Robert May, published a paper called Ecology for Bankers. Certainly not a direction I thought we'd go. And this was in the spring of 2008, where we said, well, as we start to look at the banking system, we're worried. And if we were you, we'd be even more worried, because the system is so interconnected. Who knows where the current subprime crisis will lead? And 6 months later, the markets collapsed. And I've been doing work in that arena since, and consulting with business people, insurance people, who are increasingly worried about climate change and things of that sort. So that was an unusual turn that I had no idea was going to happen. And I try to convey that to my students, which is don't try to plan too far in advance. There are going to be so many unpredictable consequences. My father was a pharmacist. He owned a drugstore. He would come home shaking his head. He'd hired some young guy to start working for him, 18 years old, 19 years old. And he said, he's asking me all kinds of questions about retirement. He couldn't believe anybody would be thinking so far in advance. And there are going to be so many twists and turns along the way. Just be prepared to deal with them like the human immune system, and be adaptive. And so I think that's the main thing that I've learned along the way is the importance of being adaptive. And that lesson makes its way into all of the research that I do, including how one ought to respond to epidemics and the advice I give in my consulting with the Boston Consulting Group.
Have you ever met your hero? I'm thinking of, like the most surreal thing where you've thought, I never would have imagined I would be standing in this one place right now. So have you met one of your heroes and sort of had that wave come over you of, oh my goodness, I'm doing this?
Well, that comes over me all the time, and it's not just one hero, but I've been so fortunate, first of all, to interact with fantastic people and collaborate with them, like George Danzig, like Kenneth Arrow, like Eleanor Ostrom. I don't want to give the list because I don't want to leave anybody out. I've profited so much. I don't know that I've stood there and all. I've also, as we all in our field, have had the benefit of traveling. And I remember my first trips internationally, walking around and thinking, I can't believe I'm here walking around. So I've had that geographic experience. But usually when it comes to, Ken Arrow, who passed away 2 or 3 years ago, was one of the most amazing people I've ever interacted with. And I'll tell you one story, which gives you an idea, which is I was puzzled by some question that I thought a brilliant economist would have better insights than I would. And I asked him at a meeting. We used to see each other once or twice a year at regular meetings. And he gave me an answer. I was satisfied. And then 4 years later, he came up to me and he said, you asked me a question 4 years ago at this meeting, and I told you this, and I've been thinking about it, and that's the wrong answer. He said, what I should have said is this, and it's a question we had to look at. So we then published a paper on it. And Arrow, who was a Nobel laureate and one of the 2 or 3 greatest economists of the last century for sure, was like a graduate student. In fact, at his 80th birthday party, or one of them that I was at, someone stood up and said, the thing about Kenneth Arrow is he never stopped being a graduate student. So, yeah, I was, constantly thinking how fortunate I was to be interacting with him and Paul Ehrlich and George Danzig and Lynn Ostrom and all of the other great people I've had the opportunity to interact. Do I think, is this really me? No, I don't have time to think about that. But as I look back, I realize how fortunate I've been with the people I've had the chance to interact with, and the institutions, and the need to constantly be adding and editing new institutions, new interactions, new collaborations. I'll tell you, some of those feelings you describe, I have just from how fortunate I am to be interacting with my graduate students and postdocs, and you heard Max Goyen give his talk last week, and the things I learned from my students and how they forced me to think about things in new ways. So
we all need to be like Ken Arrow and keep being graduate students, right?
Well, I took it away from that. That is that if I would hope that someone would say that about me. I think, and working with him, he was like a graduate student. We'd talk together, and he'd go off and do the calculations. And I thought, this is the best graduate student I've ever had. I never had one who came to me already with a Nobel Prize.
Right. How convenient would that be, right? All right, that is it for the questions that I wanted to ask you.
Well, thank you very much, Erin, and thanks for all you're doing.